You see trains every day, but almost no one realizes what is hidden in plain sight. Behind every locomotive is a carefully engineered chain of railcars, each built for a purpose most people never notice. From double-decker coaches built for speed and comfort to rolling restaurants and high-security cargo giants, these cars shape how we move people, food, and even entire factories across continents. Most of us look right past them, yet the real story of railroads is not just about the engines, it is about the unpowered cars they pull. If you love discovering how everyday infrastructure really works, subscribe now, because understanding the world's most overlooked marvels starts here. Step inside a standard passenger coach, and the logic behind every detail becomes clear. Most coaches are built around a central aisle with rows of seats, echoing the layout of an airplane cabin. This open saloon style makes it easy for people to board quickly, find a seat, and move about. In other parts of the world, you will find corridor or compartment coaches, seats grouped in small rooms along one side with a narrow passage connecting them. While compartments offer privacy, open saloon designs are favored for accessibility and efficient boarding, especially where trains make frequent stops. Modern coaches are shaped by accessibility laws like the Americans with Disabilities Act. Wide doors, low-floor entryways, spaces for wheelchairs, and accessible restrooms are now standard on new cars. These changes are not just about compliance, they make travel possible for more people and speed up station stops for everyone. Many passenger trains today use fixed train sets, where cars are semi-permanently linked and share power, brakes, and climate control. In electric or diesel multiple units, motors are spread out under the cars, giving the whole train smoother acceleration and more even weight. This setup means less time spent coupling and uncoupling cars, but it also means less flexibility to swap out car types on a whim. When demand spikes, some railroads turn to bi-level coaches, double-decker cars that can nearly double the number of seats in the same train length. But not every route is built for them. Tunnels, bridges, and overhead wires often limit their use, and extra stairs inside can slow down boarding. In places where clearances allow, though, bi-levels pack in commuters without needing longer platforms. Every choice in layout, from seat rows to door width, reflects a balance between capacity, comfort, and the physical limits of the railway itself. Beyond the rows of seats and standard coaches, rail travel has always been shaped by the cars that add comfort, culture, and a sense of occasion. Baggage cars ride up front, packed with luggage, parcels, and sometimes even pets or bikes. On routes with lighter loads, combined cars merge baggage space with a few rows of seats or crew quarters, making every foot of the train count. Dining cars, with their narrow aisles and polished tables, turned long journeys into rolling meals. From the late 1800s onward, these kitchens on wheels served full breakfast and multi-course dinners, their compact galley layouts later inspiring the look and feel of classic American diners. A cross-country trip could mean white tablecloths, real silver, and a menu that changed with the region outside your window. Lounge cars offered a place to unwind, a sofa, a drink, and wide windows for watching the world go by. At night, passengers retreated to sleeping cars. Early Pullman sleepers, first built in the 1860s, used open sections, seats by day, upper and lower berths by night, separated only by curtains. Over time, privacy became a selling point, and private rooms replaced open berths. Pullman porters, many of them black men whose work shaped both service and civil rights history, listened to travelers' complaints and helped refine the layout and amenities of these cars. Dome cars, first built by Budd in the 1940s, let passengers ride high above the roofline. Glass all around, the landscape rolling past in every direction. At the rear, observation cars offered a panoramic end of train view, while crew dormitory cars tucked away beds and offices for the people who kept the train running. These specialty cars made the journey as memorable as the destination, turning the train into more than just a way to get from one place to another. Freight railcars are built around a simple idea: move as much as possible and do it with maximum efficiency. The boxcar is the original workhorse, an enclosed rectangular car with sliding doors designed to carry everything from paper towels to packaged appliances. Unlike an open truck bed, a boxcar protects cargo from weather and theft, but it is the interior space that often sets the limit. Shippers talk about cubing out a boxcar, filling every inch with lightweight goods like pillows or cereal boxes long before the car reaches its weight limit. It is the same challenge as packing a suitcase. You run out of room before you run out of strength to lift it. Autoracks are the solution for some cargo, like new cars. These are tall, multi-level rail cars that turn a train into a rolling parking garage. Tri-level racks can carry up to 15 small cars each, while bi-level racks handle taller SUVs and pickups. In the early 1970s, the auto train gave this idea a human twist. Passengers could load their own cars near Washington, D.C., ride overnight to Florida, and wake up with their vehicle waiting for them. The original Auto Train Corporation ran from 1971 until bankruptcy in 1981. Amtrak revived the service in 1983, and it remains a favorite for families and retirees. The biggest change in freight came with the rise of containers. Standardized steel boxes, easy to transfer between ships, trucks, and trains, revolutionized global shipping. To double capacity without building taller bridges, engineers developed the well car, a flat car with a lowered center section or well that lets two containers ride one above the other while still clearing tunnels and bridges. It is like lowering a box between two chairs so you can stack another on top, fitting more under the same roof. This simple geometry turned trains into the backbone of intermodal freight, linking factories, ports, and warehouses across continents. Some rail cars are built for jobs so specialized they seem almost tailor-made for a single shipment. Coil cars cradle heavy rolls of steel, their beds shaped to keep the cargo from shifting and protected by removable hoods. Gondolas, with their open tops and solid sides, take on scrap metal, rock, or debris. For bulk materials that flow, like coal or grain, hopper cars use sloped floors and bottom doors, letting gravity do the unloading. Covered hoppers keep out rain for sensitive loads like flour or fertilizer, while open hoppers handle what does not mind the weather. When track work calls for dumping stone or soil along the rails, side dump cars tilt their bodies sideways, pouring ballast exactly where it is needed. At the far edge of what rails can move are Schnabel cars. These giants can stretch over 200 feet and ride on up to 36 axles. Instead of sitting on a flatbed, the cargo, often a power transformer weighing more than 1 million pounds, hangs suspended between two massive arms. The car itself bends and shifts, lifting or sliding the load inches at a time to squeeze past tight bridges or clear low wires. Each move takes months of planning, route surveys, and sometimes even temporary removal of obstacles along the way. Tank cars carry their own risks and require even stricter design. Non-pressurized tank cars haul everything from corn syrup to crude oil, while pressurized models with thicker steel and armored domes handle gases like chlorine or propane. After a series of high-profile accidents in the 2010s, regulators demanded safer cars. The DOT 117 standard, adopted in 2015, brought thicker shells, full-height head shields, and stronger valve protection. Today, every hazardous load must travel in a car built to survive a derailment, with clear placards and strict inspection routines. Behind every specialized car is a web of rules and engineering, all aimed at keeping both cargo and communities safe. Keeping trains running safely is not just about the cars you see rolling by, it is about the hidden fleet of machines working behind the scenes. Ballast is the crushed stone that holds the track in place, spreading the weight of every passing train and draining away water. Over time, it gets packed down or fouled, so railroads send out ballast regulators and spreaders to shape and even out the stone. The real transformation comes with tampers, sophisticated machines, many designed by Placer and Theurer, that lift the rails and vibrate heavy metal tines deep into the ballast. This process packs the stone tight under each tie, restoring the track's shape and stability. After tamping, trains can run faster and smoother, with fewer derailments and longer intervals between repairs. Rail grinders follow, shaving away tiny imperfections in the steel rail to reduce noise and wear. For the heaviest jobs, railroad cranes lift entire sections of track or move derailed cars back into place. To stay ahead of trouble, track geometry cars, outfitted with sensors and lasers, run down the rails at line speed, scanning for any sign of misalignment or weakness. Crews rely on these machines to keep the line open, often working through the night so that by sunrise the track is ready for another day of trains. For generations, the caboose was the rolling office and living quarters at the end of nearly every freight train. Conductors and brakemen watched for trouble from its cupola or bay windows, checked paperwork, and shared long hours in a space outfitted with bunks, stoves, and desks. The end of the train was a place of work, vigilance, and camaraderie, a small world of its own. By the late 1970s, that world began to shrink. Railroads introduced compact end-of-train devices, first as simple flashing markers and soon as advanced electronic boxes. These units could monitor brake pipe pressure at the rear, flash a warning light for visibility, and, using radio telemetry, transmit vital data straight to the locomotive cab. By the 1990s, federal rules in the United States and Canada recognized these electronic sentinels as full replacements for the caboose. Most mainline freights rolled on with just a coupler and a small steel box at the rear. The transition cut labor and maintenance, but it also closed the door on a way of life, trading a human lookout and shared space for a blinking red light and a stream of data. In the story of railcars, it is a reminder even the most familiar designs can be swept aside by new technology. Every railcar on the tracks today reflects a century of engineering for speed, safety, and scale. As cities grow and supply chains stretch, rail's efficiency, moving a ton nearly 500 miles per gallon, remains critical. The next time you see a train, remember, innovation is still riding the rails.